Hello, welcome. Today we'll be looking at ocean waves and tides. At the end of this lesson, you should be able to define ocean waves and tides. You should be able to classify ocean waves and tides. And then you should also be able to explain the effect of tides. What are ocean waves? Ocean waves are regularly occurring movements in the water as a result of interactions between ocean water and winds that move across the surface. It is an important phenomenon responsible for the transportation of both dissolved and particulate substances in the ocean from the oceanic areas to the coastline. Waves range from small ripples to large and destructive waves, such as storm waves and tsunamis. Waves are predominantly generated by wind motion, but they can also be generated by submarine earthquake, landslide, submarine volcanic activities, maritime vessels, as well as the gravitational attraction of the sun, the moon, and the earth. As long as wind blows, waves may grow in size up to a maximum depending on the wind speed. Fast winds generate high waves. So basically, whenever surface water moves based on interactions between the water and wind, there's going to be an occurrence of ocean waves. And whenever waves occur, it moves along with particles, and also because of the ripples of the water and the movement of the water, oxygen is also generated. And so many times areas where there are strong waves produce well oxygenated water. So waves can range from small ripples that you may find on the surface of the water to very destructive waves like storms and the tsunamis. So as long as wind blows, waves keep growing, and many times it depends on the speed of the wind, which means the higher or the stronger the speed of the wind, the faster the speed of the wind, the higher the waves it generates. Classification of waves. Waves can be classified based on shape of the waveform. Based on the shape of the waveform, we could have the progressive wave, and then we also have the standing or stationary wave. The progressive wave is that wave that moves in a definite direction, whereas the standing or stationary wave has a vertical motion, and many times it is relatively fixed. Waves can also be classified based on the depth form. Based on the depth form, we have the deep water wave. We also have the shallow water wave. Deep water wave, as the name implies, are waves that occur in deep waters. And many times they are at least half the wavelength of a given wave. When we get to different parts of a wave structure, you will get to understand what we mean by wavelength and other components of a wave structure. And so we also have the shallow water wave, which is as the name implies, waves that occur in shallow waters. Components of a wave. On our left is this image giving us the different components of a wave. So here we have the this is a conventional shape of a wave. You see this curve, this is what it looks like, shape of a wave. Okay, this shape has different components. So here we have, up here is the wave crest. Now between this point and this other point is the wavelength. Down here is the wave trough, and then this vertical distance from this point, from the crest to the trough, is the wave height. So the wave crest, from the image that we have before us, is a wave's highest point, is the highest point of a wave. The wave trough is the lowest point of a wave. The wave height is the vertical distance between a wave's highest and lowest points. The wavelength is the horizontal distance between two wave crests. And then we also have the wave amplitude, which is not indicated in the diagram. That is the vertical distance from the sea level to the highest part of the wave. This is the sea level, you see. Look at this. This is the sea level, okay? It's not, the line is not indicated in the diagram, but just look at the pointer. This is the sea level, okay? So you see, the sea level is, where the sea level is, there is this curve up, and then there's a curve below the sea level. So the one above the sea level shows us the crest. The one below the sea level shows us the trough. So the wave amplitude is that distance between the sea level, that is this vertical distance between these points, and the wave crest. In other words, the wave amplitude is half the wave height. The wave amplitude is half the wave height. Okay, so let's look at tides. Tides is the ups and downs in the level of the oceans at any given location as a result of the gravitational pull of the moon, sun, Earth's rotation working together. The main reason why tides happen is the moon's pull and its proximity to the Earth. The sun's gravitational influence is the second reason tides happen. The magnitude of the tides will increase as the moon gets closer to the Earth. The same is true of how close the Earth is to the sun, albeit the moon has a bigger impact because it is closer to the Earth than the sun is. So tides is the rising and falling of the sea level, the rising and falling of the sea water, the surface water. The water level does not just increase and decrease. It does not just rise and fall. There are, things that are responsible for that, and one of them is the moon, the other is the sun. So we are told that the strongest influence responsible for the rise and fall of water level, of sea level, is the moon. And the reason is because the moon is closer to the Earth And then second is the sun, which is not as close to the earth as the moon. So gravitational influence arising from the moon and the sun and its proximity to the earth leads to the rise and the fall of sea water. Types of tides. Tides can be classified based on tidal levels. And so based on the tidal levels, we have the high tide and the low tide. High tide is simply when ocean water level rises. Low tide is when ocean water level falls. Tide levels, which are a high tide and low tide, occur approximately every 6-hour interval. So if there is a high tide at 6 a.m. today, by 12 noon, or approximately 12:15 p.m., there's going to be another tidal occurrence. And by 6 p.m. of the same day, there's also going to be another tidal occurrence. So it occurs every 6-hour interval. Now, because of how strongly the moon's gravitational field pulls on the earth, it particularly impacts the sea's water, causing the level of water to increase and fall as the moon orbits the planet. So we have already said that the moon has the strongest impact, gravitational impact on the earth, which causes the level of the water to increase or fall every time the moon moves around the earth. Tides can also be classified based on the phases of the moon. So based on the phases of the moon, we have the spring tide, and we also have the neap tide. When the sun, the moon, and the earth are on the same line, it produces a spring tide. However, when the sun and moon are at right angle to the earth during the first and third or last quarter phases of the moon, what happens is a neap tide. A neap tide is produced. The spring tide is a stronger tide, caused mainly by the greatest impact, which is from the moon. And that happens when the moon is in its full or new phase. The neap tide is a weaker or lesser tide, caused by the lower impact of the sun Alright, so if we look at this diagram on my left, you will see up here is the spring tide, down here is the neap tide. Now you see this is the sun, this is the moon, and this is the earth. They are all at, on a straight line. They are 180 degree to one another. They're on the same line. So that is when the spring tide occurs. And you see this is a new moon, so it happens when the moon is new or full. But in a neap tide, you see the moon and the sun is at right angle to the earth. The moon and the sun is at right angle to the earth, and this tide happens when the moon is at its third quarter. It also happens when the moon is at its first quarter and also at its last quarter. So this image gives us a picture of what the spring tide and the neap tide looks like. Based on tidal patterns, tides can also be classified as a semi-daily or semi-diurnal tidal pattern. This tidal pattern is one which occurs when we have a 2 high tides and 2 low tides every day. Whenever within 24 hours there is an experience of a 2 high tides and 2 low tides, what occurs is a semi-diurnal tidal pattern. They are largely visible in the US Atlantic coast. It occurs typically when the moon is directly over the equator. And this is the tidal pattern that we find in most places on the earth. There is also a mixed semi-diurnal tidal pattern. Again, in this pattern, there is also 2 high tides and 2 low tides. But the difference between a mixed semi-diurnal tidal pattern and the previous one, which is the semi-diurnal tidal pattern, is that the latter produces 2 high tides and 2 low tides that are unequal. They don't rise and fall to the same levels. Whereas the former, the 2 high tides and the 2 low tides rise and fall to the same level, so they are equal in their tidal levels. Okay, and then lastly is the diurnal tide. Diurnal tide occurs when there is just 1 high and 1 low tide per day, and is found in regions where the moon is furthest from the equator. Example is what happens in the Gulf of Mexico. Okay, so this is a diagram showing the 3 types of tides based on their pattern. So you see, this is a diurnal tide. You see, just 1 high tide and 1 low tide within 24 hours. This is a semi-diurnal tide. You see 2 high tides. This is a high tide. This is, another, 2 high tides, another high tide. This is a low tide, and this is another low tide. And you check, they all rise to the same level, and the low tides fall to the same level within 24 hours. In a mixed semi-diurnal tide, this is a high tide, this is another high tide. This is a low tide, this is another low tide. But both high and low tides don't rise and fall to the same levels. So you could see this high tide is higher than this low tide is lower than this. Finally, the effects of tides. This steady rise and fall of the tides has a significant impact on the planet's beaches, continuously eroding and altering their characteristics. Many times sediments are returned to the ocean by receding water and are then redeposited in a different location. So whenever there is a low tide, at a point where the water recedes, it carries along sediments, oftentimes depositing them in a different location from its original location. With tides, it's possible to build dams. You see, this water flow can be employed to compress air to drive turbines. And once that happens, vast quantity of energy can be generated to produce electricity. The amount of warming or cooling water passing through a particular area is influenced by tide, which alters how the ocean currents move and ultimately the weather. Thank you. See you in our next class.